Hi everyone. So I wanted to talk a little bit about free fall before you attempted these problems. Now, free fall, you're going to use the same constant acceleration equations that you've been using because it is a constant acceleration situation. Free fall just means that an object is falling towards the Earth's surface. It's under the force of gravity from the Earth. And because it's under that influence, it's going to accelerate toward the Earth at a rate of 9.8 meters per second squared. So the acceleration of gravity, and sometimes you'll see a sub g, especially if you're in AP physics. Sometimes you'll see little g like this, but the acceleration of gravity on Earth is 9.8 meters per second squared. Now, a lot of the time we're going to be plugging in a negative 9.8 meters per second squared. In fact, most of the time we will, because usually we call it up positive, and because the acceleration of gravity is pointed downward, it's pulling things toward the Earth, the surface of the Earth. That's going to be a negative acceleration. Of course, it depends on where you put your coordinate system. If you say downwards is positive, then that 9.8 meters per second squared will be also downwards. I think that's all I wanted to say so far. I want to draw a little picture. If you have, say this is Mrs. Stewart. This is a terrible drawing. You guys, you guys will learn. I'm a very, very bad artist. So say I have a tennis ball and I throw it up into the air. Okay. Now that tennis ball is going to go up, 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 up. And then what's going to happen at the top is it's going to stop. And then it's going to come down, 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 down. So it stops at the top and then comes down, 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 like that. Now, what's happening as it's going up, 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 we know that that velocity is pointed upwards, right? So velocity is pointed upwards, but acceleration of gravity is pointed downwards. So because of that, it's slowing down, slowing down, slowing down as it's going up. When we get to the very top of that trajectory, that path, we call it a trajectory. We have a velocity of 0 at the top because that tennis ball is going to slow down, stop, and then turn around and then come back and fall toward the Earth. Now, that's really important here because we're going to use that a lot of the time in especially projectile motion problems. We use that velocity equals 0 at the top, and that's what we call the y velocity because it's the vertical velocity equals 0 at the top of that trajectory because we can find other things from that as well. And we'll have an example of something like that as well in a second. And then it's going to turn around and go down. Now, on the other side, on the other side, the velocity is pointed downwards, which means that it's a negative velocity. And we also know that the acceleration is pointed downwards, and we call that a negative acceleration. So we're going to speed up, speed up, speed up as we come back down. So if you recall when we learned about acceleration and velocity being vectors, when velocity is positive and acceleration is negative, we slow down. And when velocity is negative and acceleration is negative, we speed up, right? Because they're pointed in the same direction. So this is what happens with our free fall problems. Now, an object that's flying through the air and it's only under the influence of gravity, that's when an object is in free fall. So something like a football flying through the air like this as well, even though it has horizontal velocity, so it's traveling downfield kind of in a parabolic shape, even though it's not just up and down like this, it has horizontal velocity as well. That object is also in free fall because there's nothing else acting on it. And we'll talk more about this when we talk about forces in the Newton's laws unit. But the only force acting on this is the force of gravity, and therefore the only acceleration acting on this football as it's flying through the air is the acceleration of gravity, which is pointed downward. So we technically say that that football is also in free fall. Now, something like a plane flying through the sky, that will not be in free fall because the planes like thrusters and are causing forward motion. We have wind resistance, all that, those things that cause this object to not be in free fall. So the definition of free fall is just that we only have the acceleration of gravity because the force of gravity is the only thing acting on that object. Now I want to look at these equations again really fast. So like I said, you're going to be using these equations in these problems, except the acceleration here, when we're talking about Earth, is going to be the acceleration of gravity. Now when you plug it in, it depends of course on where you put your coordinate system in the positive direction. I like to say that the positive direction is upwards, just so I don't forget that I just randomly made it downwards or something like that. So if say I'm throwing that tennis ball into the air like this at an initial velocity of 2 meters per second, if I put my initial velocity here as 2 meters per second, I have to put in a negative 9.8 meters per second squared here. So you have to be careful. Remember your negative 9.8, that negative sign if you're saying up is positive. So acceleration here in every case is going to be 9.8, 9.8, 9.8. And it's going to be negative if you're saying up is positive. So just be really careful with your signs. And that's about it for the free fall problems. They're going to be the same type of solving like we have been doing with the constant acceleration, except now we have the acceleration of gravity.